Welcome to qnawire.
So we're given this function f of x is equal to sine 2x plus sine 4x, and we're going to use a graph of this function to try and estimate where we're concave up, concave down, and the points of inflection. So I've already graphed this using Desmos, and if we look at this graph, you can see from 0 to about somewhere a little bit before 1, somewhere around here we're concave down this whole way, and then somewhere around here we start to be concave up. And then again, somewhere like around here-ish, we're going to be turning back into concave down. And then somewhere maybe around here, we're concave up again since we're now concave up. And then the last one would maybe be somewhere around here-ish, 3.1-ish. So the first thing that I'm going to do is we're actually going to just look at the inflection points first. Well, we're going to write those down and then we'll look at the intervals of concavity. So the inflection points, the first one is going to be somewhere around here. So x is equal to around 0.8-ish. The second one is going to be at around here, somewhere around here, maybe at 1.5-ish. So we have 0.8, 1.5. And then this third one is somewhere down here, maybe 2.2-ish. And then, so we have one at 0.8, one at 1.5, and 1.2 and one at 2.2. And then this last one is probably at 3.1-ish. So, or 3 point maybe, well, I guess this is actually pi. So this is the end of our interval. So we're actually going to not include anything past this. So the only three inflection points are going to be at 0.8, around 1.5, and then around maybe 2. We'll say 2.2. So IP's inflection points at x is equal to 0.8, around 1.5, and 2.2. And now we're going to look at the intervals of concavity. So we're concave down on this first interval until our inflection point at around 0.8, and then we're concave up from 0.8 to our second inflection point, and then concave down until our third one, and then concave up until pi. So from 0 to 0.8 we're concave down, and from 1.5 to around 2.2 we're concave down. So from 0 to 0.8 and from 1.5 to 2.2. And then we're going to be concave up on the other intervals, so from 0.8 to 1.5 and from 2.2 to pi, since we're only looking at our function on the interval from 0 to pi. So now for part B, what we're going to do is look at a graph of our second derivative. So first thing I'm going to do is actually find our second derivative. So the first derivative is equal to, well, the derivative of sine is cosine, and then we have to remember to also remember this 2x in here. So we're going to use the chain rule and have cosine 2x times 2. So we have 2 cosine 2x. And then we're going to do similar thing over here, but we're going to have 4 cosine 4x. And then to find the second derivative, we're going to use the chain rule again. And the derivative of cosine is negative sine. So we're going to get negative 4, since we have to remember this 2, sine 2x minus 16 sine of 4x. And now we're going to use a graph of this function to estimate, a little bit better estimate the intervals of concavity and inflection points. So if we go back to Desmos, I have already graphed this on this Desmos. And if we look at the interval from 0 to around pi, should be maybe around here, you can see that we have 3 different inflection points that are in between our interval of 0 to pi, and they're at around 0.85-ish. So we were close on this first one, around pi over 2, so a little bit above 1.5, and then 2.29-ish. So our 3 inflection points were a little bit off, but they were all pretty close. They were within 0.1 of the actual answer for pretty much all of these. So we can say that we have an inflection point at around 0.85, at pi over 2, and at 2.3. So IPs at x is equal to 0.85, pi over 2, and the last one was 2.29. And then our concavity intervals are going to be, if we go back to our graph, we're going to be concave down wherever we're negative. So we're negative from 0 to 0.85 and from pi over 2 to 2.29. And then we're going to be positive on the other intervals. So from 0 to 0.85 and from 0 to 0.85 and from pi over 2 to 2.29. And then we're going to be concave up on the other intervals. So from 0.85 to pi over 2 and from 2.29 to pi. So these are the intervals in which we're concave up and concave down, and these are our inflection points.